Kia ora, Year 12, and welcome to another lesson on the trigonometry topic that we've been looking at. Today I'm going to cover questions which involve more than one shape put together. So let's have a look at the question here. It's the same question that's from your trigonometry textbook. Hopefully you did this on Friday. This was part of Friday's lessons, but Friday and Monday kind of go together, so I thought I'd start here. So, looking at this shape here, it's wanting you to compare the two areas of the triangles to one another. So, you need to work out the area of both triangles and then say which one is bigger in this case. So, with the shapes that you currently got, you can find the area of this shape here, because you've got the two sides and the angle between. But over here, this other shape ADC, you've only got one side and one angle. Okay, and with trigonometry, you can't do anything without three pieces of information. Okay, so we're missing a piece of information here that we're going to need to get, which if you think over to your first triangle, the ABC one, you can find out the information here, which will allow you to get some more information for this ADC triangle. So that's what we're going to do. So first step I'm going to do is I'm just going to find the area of ABC by doing a half times my A, B and C. So let's give some labels here. So I'm going to call this A, I'm going to call this B, and I'm going to call this C. So half times 7 times 12 times sine 30. Okay. I'm just going to quickly type that into a calculator, so 0.5 times 7 times 12 times sine 30 gives me an area of 21 centimetres squared. Okay, so I found the area of ABC. I'm starting there because the area is easy, and with this trigonometry assessment, you have to show at least two different skills that are relevant to the context. So I've shown one of my skills already. Showing another skill by calculating the length AC would get me an achieved criteria on this assessment. However, for merit and excellence, you're looking at finding out the whole area. Then for excellence, you're looking at how you can apply a certain constraint on that question, so to show a deeper level of understanding. So the next thing I'm going to do is find the length AC. So that is side C. So I've got two sides, I've got the angle between, I want the side that is opposite. I'm looking at three sides and one angle, so that is the cosine rule. So that is C squared equals A squared plus B squared minus 2AB cos C. Substitute what I've got, so C squared equals 7 squared plus 12 squared minus 2 lots of 7, 12 cos C. Sorry, cos 30, that is. So let me just change that back. Cos 30. So I'm just going to square root that first. So C is the square root of all of that. 7 squared plus 12 squared minus 2 lots of 7. And you can do this as two steps where you calculate this line first on your calculator and then just press square root. But I just prefer to do it all in one go. So I'm just going to type this into my calculator. Lots of 12 cos 30 gives me a side length for C as 6.89 centimetres. So I can add that information to my diagram. Oh, for some reason that didn't work. Okay, back to pencil. So 6.89 centimetres. So that is now going to allow me to work out some more information for my second triangle. So my second triangle, just going to clear that, 6.89 centimetres. I've got a side opposite an angle. I've got another side. So I've got two sides and an angle. So I'm looking at sine rule. So what I'm going to do is I'm going to work out the angle over there. And then with that angle, I can then calculate the angle between these two sides to use the area rule. So the sine rule is, I want the angle, so I'm doing sine A over A equals sine B over B. So I'm going to call my unknown angle here A. So I'm going to get rid of these labels just so I'm not confused. This is actually angle D that I'm calculating. But sine A, don't know it, over my side, 6.89 equals angle B over side B, so sine 100 over 13. So to get sine A, I have to multiply up by 6.89. So sine 100 over 13 times 6.89. A is the inverse sine of sine 100 over 13 times 6.89. So let me just quickly do that on my calculator. So inverse sine 100 over 13 times 6.89 gives me an angle for AA of 31.46 degrees. So the angle A, which is actually angle D. So that's 31.46 degrees. So to find the angle here, all I'm going to do is 180 minus 100 minus 31.46 to get the angle there as 48.54. So 48.54 degrees. Not exactly. Again, I'm leaving on my calculator the full answer, which is 48.536982225. So that when it comes to finding the area, I can get an accurate area. So I'm not going to use 48.54 in my calculation. That's just what I'm writing down for reference on my sheet of paper to communicate this is what I'm working out to whoever would be reading it. However, I'm using the full value on my calculator. So when it comes to finding the area, I get a more accurate area. So I'm just going to get rid of some of these values and scribbles now because they're getting a bit in the way, especially the labels. I tend to remove my labels as I go along, just so that I can see a bit clearer what information I have and what information is relevant. So that was 6.89 centimetres. That is 48.54 degrees in that area. Okay, so to find the area of a triangle, you need two sides and the angle between. So now I've got that, I can find the area of ADC by doing half times, well, A and B, doesn't matter which way around you do it, AB, that's C, half times 13 times 6.89 times sine 48.54 to get an area. Again, I'm going to just quickly do this on my calculator. An area of 33.56 centimetres squared. Okay, so that is my area of ADC. So the question asks you to compare the two triangles, so all I need to do now is compare the size of 33.56 centimetres squared of ADC in comparison to the size of ABC, which was 21 centimetres squared. So ADC is bigger, so triangle ADC is greater than triangle ABC. Okay, in terms of area, so area of ADC is greater than area of ABC. Okay, have a go at this question yourself, see if you can get it, and I'll go over it again in a second, so just pause the video. Okay, hopefully you've had a good go at that. This question is very similar to the last question. Again, you've got a shape ABC where you've got two sides, the angle between, which will allow you to work out the area. Your second shape only has one side, one angle, so you need to do a bit of work to find information there to then be able to work out the area. So same thing again, I'm going to work out area of ABC by doing a half AB sine C, so half ABC, half times 6 times 7 times sine 120. And remember, A and B are lowercase because of the sides, C is capital because it's an angle, and it's two sides and the angle between. So half times 6 times 7 times sine 120. Again, just going to quickly do this on my calculator. So I'm doing video slightly differently today just because of the speed aspect. It takes a lot less time to do it like this than it does to do it properly with a video feed going on. So I've just done that on my calculator. Got the answer for the area as 18.2 centimeters squared. I could have done it to 2 decimal places and said 18.19, doesn't really matter. 3 significant figures is technically enough, but I always try to do at least 1 decimal place. So that's the area of ABC. And now I'm going to work out the side length AC, so that I can use that information in my second triangle. So again, got two sides of the angle between, looking for a third sine, using the cosine rule. Same formula as before, c squared equals a squared plus b squared minus 2ab cos c. So my c side is unknown, so c squared equals 6 squared plus 7 squared minus 2, 6, 7 cos of the angle 120. Square root all of that. Okay. Again, going to quickly do it on my calculator. To get a length of C at 11.27 centimeters. Okay, again, I'm going to move on to another diagram here just to make it a bit cleaner. 11.27 centimeters. So I've got a side, angle opposite. I've got another side, so two sides and an angle. A side and an angle opposite. A side. I don't know the angle opposite that, so I must be using the sine rule. Okay, two sides, two angles. You can only use the cosine rule when the angle is between the two sides that you have the information for. So when the angles are opposite the sides, then you're using sine rule. So I'm going to use sine rule again to find out the angle here. So sine at angle D. But I'm going to call it again A, that B, that lowercase b. So sine A over 11.27 equals sine 70 over 12. Rearrange this to get A. So sine 70 over 12 times 11.27, inverse sine all of that. Okay. Quickly just going to do it on my calculator. So inverse sine 70 over 12 times my previous answer is 61.9 degrees. So the angle here is 61.9. I want the angle that is between the two sides, so I need the angle up here. So I'm going to find that by doing 180 minus 70 minus 61.9. which is 48.06 degrees. Yep. Okay. Slightly different to my previous answer because I only did it to 1 decimal place. I've given this to 2 decimal places. Again, it doesn't matter. I'm just putting that information there for the purposes of visually seeing what I'm doing. However, I'm still going to just be using the value straight from my calculator. So the area of ADC is going to be half times 12 times 11.27 times sine 48.06, okay, which is which is 50.3 centimeters squared. Okay, so let's compare the two. The area of ADC is 50.3. The area of ABC was 18.2, so obviously ADC is a lot bigger. So area of triangle ADC is greater than triangle ABC. Okay, hopefully you got that correct and was able to get to a final solution. So I've only shown 3 different skills. I've shown a sine rule, a cosine rule, and an area rule. If you get 2 out of 3 of those correct, even if you had made a mistake in calculating AC, and carried that information along to the sine rule, as long as you got the sine rule section correct, you would still get the achieved criteria, because it's an error carried forward. Okay? So let's have a look at this question. This question I don't believe was in the textbook that we gave you, however it might have been. I'm not too sure. I know it was in the original, I'm not too sure if it was in the updated one with sectors. So have a quick go at this question. Again, pause the video and I'll start up again in a second. Okay, hopefully you had a good go at this. This question is, obviously there's now 3 triangles, so it's slightly more difficult, but also it's going to test you on a few more skills. So we've got 3 triangles. We've got a triangle here, 2 sides and the angle between at the top, which we can work out the area for quickly. The triangle in the middle only has 1 piece of information on that moment, which is an angle. So we need 2 more pieces of information to be able to do anything. And the triangle at the bottom has 1 side and 2 angles, so we can't work out the area, but we can work out some other information from this. So we're going to need to find out the side length here to be able to work out the area, or the side length there to work out the area. I would suggest working out the side length here, because then we can use that to find the area of a bottom shape, plus that gives us information for the middle triangle. So finding out the side length here isn't necessary for this question, so, well, it isn't completely necessary. You can still use it to find out some information, so even if you work out that side, it's still worthwhile in some regards. So I'm going to start off with our top triangle, very similar to our previous ones. So 2 sides and the angle between. So I'm going to find the area of that top triangle. I'm going to call it triangle 1 for now. I'm going to call this triangle 2 because I know that's going to be the second one I'm looking at, because that's got information on I can work with. I'm going to call this triangle 3. So area of triangle 1 is just half times 7 times 8 times sine 110, the 2 sides and the angle between. So 0.5 times 7 times 8 times sine 110 gives me an area of 26.3 centimeters squared. And this time it's asking me to find the area of the entire shape. So once I found the area of each section, I'm just going to add it together, not much more than that. Okay. So I'm also going to stick with this triangle for now and find the length from this point to this point, okay? Just because I'm there, it will give me some information for my third triangle. It's going to be useful. So I'm going to use a cosine rule again. Let's just call that, well, let's call it AC for now. We keep calling it AC, so I'm going to find the length of AC. Oh, in fact, no, if I called that C, I would call that B. So actually, I'm looking at the length of AB, if I actually label it up properly. Although I've labelled those back to front now. So that's B, and that is A. So I'm going to find the length of AB. So that would be C squared is equal to A squared plus B squared minus 2 lots of A, B, cos C. Okay. Square root all of the previous line. I'm not going to write it out again. You've seen it enough times for you to understand what's going on. So I'm just going to type that into my calculator. So square root 7 squared plus 8 squared minus 2 lots of 7 lots of 8 cos 110 gives me a length of C at 12.3 meters. In fact, I realise now my area up here should have been meters squared, not centimeters squared. Make sure you get the correct units. They are important for the assessment. So you are going to be required to do it. So, got that length at 12.3 meters. Okay, so I'm going to look at triangle 2 now. Again, I'm going to just get rid of all that information. That was 12.3 meters. Not going to help us with triangle 2, but it's worth keeping it there just in general. Okay, so looking at triangle 2 now, I need to find the area, and I need to find out the length of either one of those two sides to find the area, but preferably this side because it'll help me with my triangle 3. Okay, so I've got two angles and I've got a side, so I know when I'm talking about two angles on a side, I'm really looking at the sine rule. However, with a sine rule, I need the angle that is opposite the side that I've been given. Hopefully you worked out what you needed to do here, which is just the basic 180 minus the other two angles. So you should have done 180 minus 100 minus 35 to get the angle there at 45 degrees. Okay, so that was the first step. Now that I've got that side and that angle, if I want to find the side opposite, the side here, sorry, I need to use the angle opposite, which is 100. So I'm going to call that side A, that B, that B, okay? And I'm looking at the side, so I'm using A over sine A this time, just to make it easier in my rearrangements. So my unknown A over sine 100 is equal to B, which is 7.5 over sine 100. Sorry, I got that wrong. Sine 45. Sine 45. There we go. Yeah. Okay, to find A, then I just need to do 7.5 times sine 45 times sine 100 to give me a length at A of, so 7.5 over sine 100 times, over sine 45 times sine 100 is 10.45 meters. Or I could have done it as 10.4 meters. But I'm going to do it to 2 decimal places. Technically, the other side up there, 12.3 meters, is to 2 decimal places, because the second decimal place was 0 and the third decimal place was 0, so it rounded to 2 decimal places as 12.3 meters anyway. So I found the length there at 10.45 meters. Now I just want to find the area of that shape, so if I call the angle between A and B C, I can use my area. So area of triangle 2 is going to be a half times 10.45 times 7.5 times sine 35, which gives me an area, quickly on my calculator, of 22.47 meters squared. Okay, so that's triangle 2. Now I just need to work out information for triangle 3. So I've now given my triangle 3 two sides and an angle. So I've got 3 pieces of information. I can use that to work out something now. So let's have a look at it. 10.45, 12.3, triangle 3. Okay, so 2 sides, 1 angle. The angle is not between the 2 sides, so I can't use cosine rule, so I must be using sine rule. I've got a side, opposite, and angle. I've got side. I can then use that to work out the opposite angle. Because I want to find the area, I want to find the angle between the 2 sides, which is the angle up here. So that's the angle I eventually want. But I'm just going to use a sine rule to work out this angle, and then use angles in a triangle to work out the top angle. So let's call my unknown angle A, side opposite A, other angle B with this angle side opposite B. So I'm using sine A over A equals sine B over B now. So I don't know A, well capital A, I do know lowercase, 12.3 equals sine 40 over 10.45. Rearrange this to become sine 40 over 10.45 times 12.3. Then do the inverse sine to get this size of the angle. Okay, so again quickly on the calculator, inverse sine 40 over 10.45 times 12.3 equals 49.16. degrees. Okay, which means the angle at the top is 180 minus 40 minus 49.16. So 180 minus 40 minus my previous answer, which is 90.84, sorry, 90.84 degrees. I've got A, I've got B, this is my C. So, sorry, size of angle, area of triangle 3 is going to be a half times 12.3 times 10.45 times sine 90.84, which is 12.3 times 10.45 times sine of my previous answer is 64.26 centimeter. 64.26 meters squared. So to find the area of the entire shape, I just need to add up my. To find the area of the entire shape, I just need to add the previous 3 sides together, 3 areas together. So that is 26.3, 22.47, and 64.26. So, I can't remember those off the top of my head. There we go. 26.3, 22.47, plus 64.26. Okay, so quickly on my calculator. Is 113.8 0.03 meters squared. Okay, so hopefully you got that. That was a bit of a long one. It's more like what an actual assessment question might look like. So it's allowed you to show multiple skills there, regards to sine rule area, sine rule length, sine rule side, cosine length, and area. So lots of different ways to get marks on this one. Okay, gonna have a look at another question. This is a bit more basic than this question we've just looked at, but involves the sectors stuff. So we've got a shape here, kind of kite looking. I think it might actually be a kite. AB and AD are radii, BC and DC are tangents. Yeah, it is actually a kite. I don't know if you need this information, but I don't know how much information to do with circle frames you're going to need on this. But let's have a look at it. Pause the video and see if you can have a go at this question yourself, and then I'll do it myself. Okay. Right, hopefully you've had a go at that question. So, it's asking you to find the shaded pink region here. So, to do that, you're going to need to find the area of the entire shape and then take away the area of a sector. First thing I'm going to do though is I'm going to do the area of sector, because area of sector is really easy, so it's a quick skill to show without making any mistakes. So, area of a sector is theta over 360 times pi squared. So our theta is 118 over 360 times pi times 2.9 squared. Quickly on the calculator. Is 8.66 meters squared. So that's the area of a sector. Now I need to find out some information for the rest of the shape. So let's have a look at it. It's two triangles put together. So if I drop in a line BD, I can work out the area of ABD, or the area then the area of BCD, put them together and take away the area of a sector. I could have also dropped in a line from A to C, but you would have had to know that that would create an angle bisector at A. But then you could have used the area of ABC and then just added it together. I think both I'm going to need to use a bit of extra information on that you don't necessarily know, which is that BC and DC will be the same length, because if you have tangents from a circle to a point, they are the same length. In fact, I might actually just use the first one, the fact that AC is an angle bisector, because it will be easier in the long run, and it does use some circle theorem knowledge. So you might have struggled a bit more with this if you don't remember circle theorems, or if you didn't cover this last year with your circle theorems, which you may not have. But AC will be the easier way to go, so I'm just going to do that one. So I'm just going to get rid of that other line ABC. So back to here. Oh, it never goes away when I want it to go. There we go. So I'm going to drop in a line here. So if I draw that triangle out at the bottom, what I have is an angle here of 59 degrees, because it's a bisector. This side here at 2.9 meters, this side here at 5.2 meters. To find the area of a triangle, I want to know the angle between. However, I've got two sides of an angle, I don't have the angle between, so I can't use cosine rule or the area rule. So let's have a look at what else I've got. I've got a side opposite an angle, I've got a side opposite this angle, then I can use angles in a triangle to work out the top angle. So let's call this angle A, A, B, B. So sine A over 2.9 equals sine 59 over 5.2. So sine A is sine 59 over 5.2 times 2.9. So A is the inverse sine of all of that. Okay, I'm not going to write it out because I've written that out enough times today and in the past. So hopefully you follow it enough. So inverse sine of sine 59 over 5.2 times 2.9 is 28.56 degrees. Okay, which means the angle at the top is 180 minus 59 minus 28.56, which is 92.44. Okay, so to find the area of ABC, I'm just going to go onto another page again. So 2.9, 5.2, what's the angle there? 92.44. So to find the area of that, it's just a half over 2 sides times by sine of the angle between. On the calculator, is 7.53 meters squared. Okay, so that would have been half of the overall kite shape. So 7.53 meters squared. So the overall kite would be 7.53 times 2. And then to find the area of a pink, I've got the overall area of a kite, 7.53 times 2, minus my previous area, which was 8.66. So this is shaded area. Okay. So times 2 minus 8.66 gives me an overall shaded area of 6.41 meters squared. Okay. Hopefully you got that. That one was harder in the sense of you had to know some circle theorem stuff. In the actual assessment you won't need to know your circle theorem and stuff. So don't worry too much about that if you didn't get that part. But the real test was, could you remember how to do the area of a sector? Okay. That's the only difference to the previous questions. If you found the previous questions fine and you found the area of sector, but you couldn't work out the rest of it, you're on the right track. This question was just a bit more complicated than I realised when I put it together. Okay, hopefully you got that. I'll do a walkthrough on one of the practice assessments. Okay, I think 2 of them already have solutions to them, so just try and use those for now, and I'll do a video on one of the other ones at some point. Okay, hope you're all staying safe and have a great day.